In this video, we're going to take a look at Go's FMT or format package. We're going to take a little bit of a deep dive into printf, the format verbs and templates within the package, and what makes it so powerful and why it's so useful. So format verbs are template placeholders that tell Go basically exactly how to display your data. And we've seen this a bit before, but let's take a quick example and see exactly what I mean here. So let's just create a name. We'll say Alice. And then we can use fmt.printf, as we've seen quite a lot before. They're going to use what's known as a format verb. So this is the percent symbol, and then S for string, and we'll just add a new line here, and then we'll print out the name. We can do the same for various other verbs as well. So we'll do Q, we'll do a pound, pound V, and we'll do a capital T as well. If we go ahead and run this code, we should see we get some kind of output, as we would expect. So we can see that here, the S is for string, Q is for string with quotes, pound V is for what's known as Go syntax, and we'll discover that a bit more later on, and T is for the actual type itself. And essentially these are format verbs, and these format verbs tell printf to format the data differently, depending on obviously which verb you use. And we'll dive into these a bit more and understand exactly which each one does and when you should use them. Okay, so let's take a look at another example then. Let's do fmt.printf, and we'll just use hello. We'll do the string verb, and we'll then do a digit verb, so for number, for digit. And we'll just say, hello, you are X years old, and we'll do Bob, and Bob is 44. We'll then go ahead and do another example here. We'll say, let's go ahead and say first is a string, second is another string, and third is another string as well. And then we'll just do A, B, and C. If we go ahead and log this out again, we should see we get, hello, Bob, you are 44 years old, as an integer, as you would expect. We then just get first A, B, C. And so ultimately, the format verb tells Go how to interpret and display the data. So %s means treat this as a string, %d means treat this as a decimal. The argument after the template string, fill placeholders in. So this is going to fill in the first placeholder, this is going to fill in the second placeholder, and obviously this is going to fill in the third placeholder. So obviously each of these template strings represent the argument you pass in the correct order. So 1, 2, 3, as we would expect. So let's take another look at all of the template strings in a simple example. We can kind of talk about those a bit more. So let's just do some text here. We'll say hello world. We'll then do text with special chart, and let's do line 1, and we'll have a line break. We'll do line 2, and we'll have a tab, and we'll just say tab as well. Let's go ahead and print these out. So printf, as we've seen before, and this time we'll do %s, and that's just going to cancel out the first percent so we actually see what the output is. We'll then do raw string, because that's what this one is, and then we'll actually output the string itself. And then we'll output text. So just to be clear, this percent here will basically cancel out this percent, so we should see %s in the output of the text, just so we can see kind of what the template verb, the format verb actually is. We'll then do the same for quotes. So this should be quoted, and we'll say Q for quoted. Let's go ahead and do another one for value. So this is just going to be the value of the variable we pass in this case a string. And let's do another one. This time it's going to be the pound symbol and V, and this is what's known as Go syntax. It kind of won't make much sense in this one because it's just a string, but we'll see that later on, a bit better example. And we'll do a final one, %t, which is the type. So this will say string. Okay, let's go ahead and run this. Oh, we've not used this one, so let's just cancel that for now, and we'll come back to that in a second. Okay, so we see %s, we get a raw string, as we'd expect. %q, we get the quoted string. %v, we get the actual value, in this case, just the string value. %v, that's the Go syntax. Okay, doesn't really make sense for a string, but we'll see that a bit more later on. And then %t, the type itself, which is just the type of the actual value. Let's go ahead and look at the example now with that special characters in the string. So with %s, and we'll do the template, that, and then let's uncomment this one. Text with special character, and then we'll quote it as well on the next one. Okay, so let's run that, and we'll see that we get, with the special character, we're actually including that special character and rendering it as we want. So we've got new line, and then a tab. So that's what we get out when we use %s. But when you quote it, it just essentially adds those as you see them in the code. So you get the actual representation of a new line rather than a new line itself. Okay, so let's do the same for digits, and we can run through some examples here. So we'll do number 42, and we'll do large number, and we'll call this 255. So again, fmt.printf is what we're going to be using. And again, we'll use the escape. So we'll do decimal here, and then we'll just do %d, and we'll stick a new line in there as well. So let's just put number. We can also represent this as binary using the B character. So this will be binary B. We can do base 8, so octal as well with the O. So this will be octal O. What else can we do? We can do a hex representation as well using the X character. So this will be hex, and this is going to be lowercase. You can also do that in uppercase with making the X uppercase. Nice and simple there. And of course, we can also see the value as well. Again, let's just do value, and that's going to be V. And again, we can also do the type, as we saw earlier with strings. This will be the type, capital T. And then we can also print out in a bit more of a real example. Let's do decimal, so we'll do %d here. We can do binary, we can do %b for binary. We can then do hex, so let's do %x, and we'll do octal as well for %o, and then we'll just dump in a new line there as well to see what's going on. And then let's pass in the large number, large number, large number, and large number again, just so we can see all of those in one particular string. Okay, let's print this out then. So as we can see, %d shows the decimal, so base 10, basically what we use every day. %b shows the binary, and obviously this is the ones and zeros that the computer actually uses and interprets. We can use %o for octal, which is base 8, which is basically still used in Linux file permissions, if you ever use those. %x lowercase, you get the hex. %x uppercase, you get the uppercase. This is hexadecimal or base 16, and you'll see this a lot in kind of memory addresses, or if you've ever done CSS, you'll see it used for color codes. %v for integers, basically the same as %d, and then %t, we get the type. So in this case, it's an int. And then, of course, in our example, we just output all of them. We get, for the large number, we get the decimal, we get the binary, we get the hex value, and then we get the octal value. So nice and useful to know for decimals. Then let's have a look at some example with slices as well. So we'll just create, oh, I think I deleted that. So we'll create a slice here of integers, and we'll just do 1, 2, 3, 4, 5. Let's go ahead and do cities. So maybe a slice of strings. And we'll do, I don't know, New York. Let's do London, and let's do Tokyo. Okay, so then we can use the printf function again, as we've seen. Again, we're going to use the verbs, and we'll do %v for the value. This is also known as standard for slices, so %v, and then we'll drop the new line in here, and then we'll just output nums. Let's go ahead and do the Go syntax one, and this is where you'll kind of see what Go syntax actually means, as it's not quite clear with strings and integers. We'll then do the type as well, so we need to do %t. Oh, we've got a typo there, we need to do that twice so we can actually see what's going on. Percent there, yep. Okay, so we'll do the type with capital T. Let's also do for the strings slice as well. So we can just do standard here. And we'll output the cities. And we'll do quoted as well. So you can see that that works for slices as well. Oh, no, I'll percent Q there, don't I? Okay, so if we go ahead and run this, we should see some interesting output. So we can see that for %v, or the standard, you just get basically the slice outputted with the values as you would kind of expect. With the pound symbol and then v, you get what's known as the Go syntax. I saw this before with the strings integers, but it just looked the same. But you can see here with the slice, it's kind of the actual code representation, so the actual Go syntax. And that's quite useful if you're ever going to be outputting the raw code and want to see that. We've got a type, again, just the type of the slice. And then, of course, we've got with the slice of strings, we get the values of the strings, and then you can also have them quoted as well. Okay, so that's basically most of what I want to cover with printf, but one thing I want to cover as well is writing to standard error and other outputs, because so far we've basically been writing to standard output, but the FMT package can write to different outputs, so standard error, for example. Let's just have a look at that quickly, and then we'll wrap up this video. So I'm also going to import the OS package here, as I'll be needing to write to various OS outputs. Oh, don't need a comma there. Okay, so let's go ahead and just write a string. We'll just say Tim. And we'll use the printf function as we've seen. Oh, this is not very happy with me there. So printf, and we'll just output, regular output, and we'll do the string verb, and we'll just output our name. So that's the standard with printf, it goes to the standard output. If we want to write to, for example, standard error, we can use the fmt.fprintf function. So this takes a writer, which in this case will be os.standerror, and then we can do, for example, error, I don't know, user not found, and we'll add in our name there, and we'll just pass that in as well. You could also explicitly write to standard output if you wanted to. Let's just say this is just explicit. You wouldn't actually see any difference in the terminal here, but it's just kind of useful to know that you can do it if you want to. So I think that's all we need to know for that one. So let's go ahead and run this, and you'll see that we get some output here. Oh, I didn't add any new lines. So let's just quickly add in those just to make it clearer. Run that again. And again, you kind of see the outputs there. Obviously, you don't see standard error as anything different from the output here in my terminal. I don't have any formatting or anything going on. But basically, you can use the standard error output or whatever you want to particularly use for your OS and your output here. And why do you use this? Well, obviously, when you have error messages and debugging info, they should go to standard error so they don't interfere with the program's main output. And this is really important when you're using kind of logging and kind of things like Grafana or Datadog. And especially important when your program's output is basically being piped to another output command, basically. So before we just wrap up, let's have a look at printf versus println and when you should use one versus the other. So we'll stick with the name here. We'll go with age as well. So 35. Let's go ahead and do quick output, and we'll do name, age. And rather than printf here, I'm going to use println, which you've seen a fair amount in the examples. We'll also do printf below, and basically we'll do the type, info, so %t, Let's do, and we'll do the %q for the quoted, and let's just say is %d for the digits, and there we go. So then we just go ahead and put, for example, name, and age. And if we just run this, we'll see the difference between the two. So with print line, for example, it's one line, you get the spacing done by default with the outputs, and it's just a quick, nice way to output something quickly. Generally use print line for kind of quick debugging when you want the automatic spacing, and you can use printf when you need the formatting verbs like %t, %q, as we've seen before. Or you want some kind of precise control over your output formatting. So to wrap up, the Go FMT package is really useful. You'll use it pretty much in every program that you write. And we now know a bit about the format verbs, so %s, %q, %v, %v, %t, and all the other ones that are very useful. You can also use the fprintf function to write to standard error, standard output, or any other writer that you have. And that's it basically. It's quite a simple package, but it's very useful to know, and I just wanted to do a quick video diving into that explicitly.